Firearm and tool mark identification involves comparisons, such as the rifling marks on bullets, to determine if they share a common source firearm. Traditionally, examiners have used comparison microscopes to view objects two at a time. However, their use can be challenging and time-consuming, due in part to the frequent position adjustments and varying lighting conditions. In recent years, there's been increasing pressure for objectivity in expert conclusions, amid court concerns about reliability and a lack of a statistical foundation for these conclusions. As is often the case, we turn to technological innovation for solutions. The solution is 3D microscopy. It provides on-screen display of 3D surfaces without being affected by inconsistent viewing conditions, and without the need to constantly and meticulously reposition the objects. 3D microscopy allows reliable 3D measurements of surface marks that are needed to achieve objectivity, because these 3D measurements are well suited for mathematical comparison algorithms used to quantify similarities. Statistical models can then be devised to provide assessments on the probability that two tool marks share a common source. The Quantum 3D microscope combines all these technological innovations. It provides firearm examiners with the best 3D visual and quantitative analysis tools for objective conclusions. Leveraging proven IBIS technology, Quantum uses a custom-designed 3D sensor and comparison viewer. The first Quantum model, the S1, is specialized for bullets and similar small objects. It also includes groundbreaking quantitative analysis capabilities based on line counting and pattern matching scores. The Quantum 3D microscope was designed to assist expert conclusions for common source determinations and testimony. For bullet case work, each item is first acquired to obtain its 3D topography. Test fires and crime evidence, including damaged and fragmented bullets, can be easily mounted for 3D capture. The process is automated and only requires an initial setup and subsequent quality control by the operator. The items can then be compared side by side on screen. Since viewing is based on the 3D topography, virtual comparison microscopy can be very effective, with the many display controls available to the user. Quantum's high-quality 3D viewing and intuitive operation enable a firearm examiner to reach conclusions rapidly and confidently. The leap in technological innovation is most evident with Quantum's quantitative analysis capabilities, where the 3D topography measurements are compared using algorithms that generate objective similarity scores. These scores are plotted on Quantum's unique RBL graph, where we can easily see the strength of agreement and the separation of matches and non-matches. Statistical modeling can provide confidence levels and error rates, such as the false match rate. This measure represents the probability that two bullets that were not fired from the same firearm would generate a greater score. Every aspect of the work can be saved in notes and snapshots for future reference and to be included in reports. Overall, using Quantum can be much faster than working with a conventional light microscope, especially for more complex casework. The Quantum 3D microscope is also useful for research and studies, as well as for training and proficiency testing. New methodologies and best practices can be imagined as it becomes easy to share sets of 3D acquisitions with others. Quantum has laid the foundation for more innovations to come, such as new objective measures and a similar product for cartridge cases. This is a game changer for firearm and tool mark examiners, innovating today for a safer tomorrow.